In Townsend State Park in southern Vermont, tall hemlock trees soar. One of the most common and important trees in the eastern United States, hemlock trees provide shade for picnickers, cover for deer in winter, and cool streams for fish in summer. Dozens of bird species depend on hemlock's dense branches. But hemlock trees from Georgia to New England are dying by the millions.
Well, a hemlock woolly adelgid is an insect that invaded the United States from Japan in the early 1950s, and it's been destroying hemlock trees in the Northeast ever since. Well, what we're trying to find out today is, can we control this hemlock woolly adelgid through ground applications? Are we going to be able to use fungi to suppress this invasive pest? Well, we have a fungus that's called Leconicillium muscarium. It's actually a registered product that comes from the Netherlands and used in a number of different countries. But it's also ubiquitous throughout the world and also already found in the hemlock woolly adelgid ecosystem. So it's not novel fungus that's coming in there. It's an insect-killing fungus. What it does is when the insect comes in contact with the fungus germinates just like a seed, penetrates into the insect, and then proliferates and kills it, and then reemerges and releases more spores into the environment to kill other insects. And the hope is that we have major disease outbreaks that suppress the hemlock woolly adelgid populations. Well, we have a special technology that is licensed from the University of Vermont that was developed in my laboratory there, and it's called wave-based microfactory technology, and it's very unique. What we do is we allow the fungus to grow in this special formulation after it's released out into the environment. So you get a lot more bang for your buck, essentially. And it's been a really big problem in trying to use fungi to control insects and diseases and other applications, because they cost a little bit too much to use, and it takes a little bit too much to really be effective. And so what we do now is we take the mass production, the growing of the fungus, out of the factory, the bricks and mortar factory, and we transfer that out into the field. So it's basically a formulation additive. We call it Mycomax. And we mix the fungus, a registered biopesticide, with this natural formulation additive based on sweet whey, which comes from cheese production. It's a byproduct. And once they get out into the environment under suitable conditions of nice relative humidity and warm enough temperatures, the fungus grows and it mass produces out in the field. So we have an experiment. We spray 10 trees, we leave 10 trees unsprayed, and we come back in a month and then in the winter and see if we had control taking place.
Back on campus several months later, Costa continues his experiment, looking to see if the fungus knocked back the adelgid.
So now what I'll have to do is go through a lot of samples. I have 20 different trees that we collected foliage from, and 5 branches from each tree, and I'll go and I'll examine 5 twigs, 5 small little twigs, and preferably of new growth, and I'll do that microscopically, and I'll just go through and determine the number of alive and a dead adelgid, and I'll do that by puncturing each of the hundreds and hundreds of adelgids that I see. So what we're looking at is a small part of a hemlock branch, and there's a stem with hemlock needles on them, and I see at least a dozen adelgid there. And go through and I squish it, and these are pretty dry. Oh, that one was juicy. That juice was pretty dark colored though. It's more brownish than pinkish, and that indicates that it's about to die. It has to be a nice reddish pink color. That one's dead. A lot of dead here. Those that do survive will go on. Each individual will produce 100 to 150 of its own offspring, and each of those will produce 100 to 150 of their offspring in 1 year. And so each individual ultimately results in about 10,000 adelgids. And that's why we see these explosive population outbreaks. we want to make the trees look like the one over here. You can see the new growth. It's light colored. Each stem has new growth coming up on it. Here, this is last year's growth. There's no new growth here at all. The tree's being suppressed by the adelgid.
The adelgid has devastated hemlock forests in the Appalachians. With no natural predators in the United States, it is rapidly marching north. Last year, Costa tested his fungal factory in large forest plots in Tennessee, spraying the fungus from helicopters. But would it work in Vermont on single trees sprayed from the ground?
What we discovered is that we can use fungi to control hemlock woolly adelgid populations. We had a successful experiment. We took fungi, we sprayed them out there, and the insect population where the fungi were stopped growing. Whereas when our control, where no fungi was sprayed, the hemlock woolly adelgid population continued to grow. There were almost 3 times as many insects on the controls, on the untreated branches, as there were on those that had received the fungus. So the experiment was a success.